Assalamualaikum warahmatullahi wabarakatuh. We are presenting the video assignment for our group. Okay, based on the floor plan that given, I would like to describe about the MDF, which is MDF is a short for main distribution frame, a cable rack that interconnects and manages the telecommunication wiring between itself and any number of IDF. Main distribution frame or MDF is a signal distribution frame for connecting equipment which is inside plants to cables and subscriber carrier equipment which is outside plants. The location for MDF can vary large buildings such as a ground floor. The MDF can connect in private or public lines coming into a building with the internal network. For large buildings are usually locked in a communication room and require access from a building manager. For this assignment, a building with two-level floor have one centralized MDF on the first floor located at the first floor and a few telecommunication wiring closet on each of the floor is connected to MDF. Alright, there are two requirements of MDF, which is there are only be one MDF in any high-rise apartment building or flats. Second, provide flexibility in assigning telecommunication facilities at a lower cost and higher capacity than a patch panel. Alright, next is telecommunication wiring closet, which called TWC. TWC is a small room that encloses telecommunications, network, system, and device. This closet is the central junction point for all wiring equipment and wiring for device connected in a LAN, which is local area network. It often contains access to wiring conduits large enough for service personnel to access in order to service or install cabling network within buildings. Alright, the requirement of TWC is minimum ceiling height 2.6 meters, false ceiling forbidden. TC size based on the service area, at least 1 meter equipment and cross network clearance, appropriate grounding and bounding for cable, shield and metallic pathway. And last, multiple TC interconnectivity by floor. Alright, next is a type of cable. The cable that used in the floor plan is horizontal cabling. Any cabling that is used to connect a floor wiring closer to wall plates in the work area to provide local area network, which is LAN, drops for connecting users' computer to the network. Horizontal cabling is easy to install during construction or renovation of the building because proper installation might require opening false ceiling or walls.
So I continue with the access point. An access point is a device such as a wireless router that allows wireless device to connect to a network. Most access points have built-in routers, which others must be connected to a router in order to provide network access. In either case, access points access points are typically hardwired to other devices, such as network switches or broadband modems. Access points can be found in many places, including house, business, and public location. In most houses, the access point is a wireless router, which is connected to a DSL or cable modem. However, some modems may include wireless capabilities, making the modem itself the access point. Large business often provide several access points, which allow employees to wirelessly connect to a central network from a wide range of locations. Public access points can be found in stores or coffee shops, restaurants, library, and other locations. Some cities provide public access points in the form of wireless transmitters that are connected to street light, sign, and other public object. While access points typically provide wireless access to the internet, some are intended only to provide access to a closed network. For example, a business may provide secure access points to its employee so they can wirelessly access files from a network server. Also, most access points provide Wi-Fi access, but it is possible for an access point to refer to a Bluetooth device or other type of wireless connection. However, the purpose of most access point is to provide internet access to connected users. Okay, now how does a wireless access point work? Okay, access point work by connecting direct to your broadband router or network switch with a Ethernet or data cable. This provide the AP with the internet connection and bandwidth required. It then transmits and receives a wireless signal in either for 2.4 GHz or 5 GHz frequency range that is Wi-Fi. This allow you to connect wireless to your local area network and the internet of the building. Thank you.
Type of access point. Standalone access point. A standalone access point provides the same functionalities in wireless network which a switch or hub provide in the wire network. It provides connectivity between the different wireless device. It accepts frame from the connected device and based on its physical address, forward it to the destination device. Both of the wire network and the wireless network use the different networking standard. Wire network use the Internet standard while the wireless network uses the IEEE 802.11 or Wi-Fi standards. A device which only understands and supports the one type of the standard from the Ethernet standard and the Wi-Fi standard cannot process the frame that is formatted in the other type of standard. For example, a regular Ethernet with switch neither understand the frame format in the Wi-Fi standard nor process it. Access points support both standard based on the destination device. Is convert the receive frame before forwarding it. For example, if it receive a frame that format with the Wi-Fi standard and have destination address, the user Ethernet standard it formats that frame with the Ethernet standard before forwarding it to the destination. Number two, multifunction access point. A multifunction access point is the combination of two or more devices. In this combination, an additional device or device are merged with the access point to provide the additional functionalities along with existing functionalities of the access point. A wireless router which ISP uses to provide to the internet connection is the perfect example of the multifunction access point. It consists three devices: an access point, an access point, a regular Ethernet switch, and a router. Number 3, controller access point. A controller access point works as the client of the wireless LAN controller WLC. Technically, a control access point is known as the lightweight access point, LWAP. LWAP doesn't take any forwarding decision. Upon receiving a frame from the connected device, instead of the forwarding it to the destination device, it forward that frame to the WLC. The WLC, based on the security configuration, make decision whether the received frame should be forwarded or discarded. If the frame need to be forwarded, then it sends that frame to the WLP, to which the destination device is connected. Then that LWAP send this frame to the destination device. The WLC LWAP setup is usually used in the company environment to span a single wireless network in a larger geographical area. This setup allows users to roam around the office premise, campus, or building and stay connected to the network. In this setup, it doesn't make any difference which LWAP a user uses to send and receive the frame, as long as that LWAP is controlled by the same WLC. Since all forwarding decisions are taken by the WLC, and LWAP does not allow direct communication between the two devices, even if they both are connected with it. Key point: access point connected multiple wireless devices together in a single wireless network. Access points support both types of standard Ethernet and Wi-Fi. Access point uses radio signal to provide the connectivity. Based on the functionalities, an access point can be categorized in the three types: standalone, multifunction, and client. A standalone access point works in the wireless network exactly as the switch works in the wired network. To control the unauthorized access point uses authorization. To extend the coverage area, multi-access points are used together under a wireless LAN controller. An access point which works under the WLC is known as the LWAP lightweight access point. In the WLC LWAP setup, the WLC control and manage all LWAP. LWAP works as the bridge between the WLC and the end device. That's all.
A wireless network range can vary widely depending on the type of network. A standard home network using one wireless router can serve a single family dwelling, but often not much more. Business networks with grid of access points can serve large office buildings, and wireless hotspots spanning several square miles have been built in some cities. The cost to build and maintain this network increased significantly as the range increased, of course. A general rule of thumb in home networking says that Wi-Fi routers operating on the 2.4 GHz band can reach up to 150 feet indoors and 300 feet outdoors. Although 802.11 AC routers that run on 5 GHz bands reach approximately one-third of this distance. Newer 802.11n and 802.11 AC routers that operate on both 2.4 GHz and 5 GHz band reach greater distance. Tips: because it uses narrower wavelength, a 5 GHz Wi-Fi connection is more susceptible to obstructions than 2.4 GHz connection, and so will usually have a slightly shorter effective range, typically 10 to 15 feet shorter. Factors influencing range. There are three main factors that influence your Wi-Fi range. The access point or the router itself, the structure you are in, and the wireless standard you are using. Okay, the first is access point or router. The Wi-Fi signal range of any given access point varies significantly from device to device. Factors that determine the range of an access point include the specific 802.11 protocol it runs, the strength of its device transmitter, and the nature of physical obstruction and radio interference in the surrounding area. The distance at which someone can connect to an access point varies depending on antenna orientation. Smartphone users, in particular, may see their connection strength increase or decrease simply by turning the device at different angles. Furthermore, some access points use directional antennas that enable longer reach in areas that antenna is pointing, but shorter reach in other areas. Tips: change the antenna that comes with your router if you are not getting the signal strength you need. Okay, the second is type or structure or building. Physically, obstruction in homes such as brick walls and metal frames or siding can reduce the range of a Wi-Fi network by 25% or more. A Wi-Fi signal weakens every time it encounters an obstruction, which happens a lot in indoor, thanks to the wall, floors, or even an electronic interference caused by appliance. The third is wireless standard. The wireless standard you are using has a direct effect on your wireless signal range and strength. The 802.11g protocol has an indoor range of 125 feet, while 802.11n has a range of 235 feet.
Hi, Assalamualaikum. So let's talk about the costing. We will discuss about the correct costing assumption and back up with good justification and price difference. So basically, there are two types of network. First is wired network, and second is wireless network. So let's talk about the wired first. So a wired network connection is basically involve cable which establish a connection to the internet and other device within the network. The data is transferred from one device to another using internet cables. For the cost of the wired network, it is depend on the configuration. Having an internet cables, switch, routers, and other hardware are actually expensive to install, and it needs some time before hardware need to be upgraded. For the building, we can assume that it might cost about 400 ringgit to 1,700 because the installation cost depends on the scope of the work. Some company offer a free basic installation, but if it looks quite complex that you want to link to the printers, multiple computers, and game consoles, it could be increase the cost. Second is wireless network. Wireless network are configurations that operate on radio frequency or microwave signals. The radio signals allow the wireless to enable the device to communicate with one another without having to be connected to the network via Ethernet cable. For the cost of the wireless network, the range price is quite same as wired network. However, it will have an additional pay for wireless repeater and commercial grade router. The wireless repeater is to increase signal, basically to increase signal strength, and commercial grade router provides more reliable connection and improve security controls. The two can be cost from 100 ringgit to 400 ringgit, and the price can be up to 1000. The wireless network cost can be very same like the wired network. The installation cost is based on the scope of work. According to the building plan, we'll be looking at the complex network setup that unites multiple computers in cyber cafe and office, printers and TVs. So the budget are from 400 to 1200 or more.